Hi everyone, and once again, I do apologize I'm not teaching you this lesson in person, but I hope this video is helpful to learn about rewriting equations and formulas from the last section of chapter 3. We are going to be dealing with literal equations for a majority of this chapter, and those are different equations where the variables will represent different known values dependent upon the scenario. So one example of the literal equation is this one I have written here where it says ax plus b is equal to c. And I will have given you the values for a, b, and c. So in this example here, I would have told you that a was given the value of 4, and then b was given the value of 6, and then c, oops, we wanted to do a different color, and then c would be given the value of 20. And oftentimes I'll ask you to rewrite this literal equation to solve for x. And remember that the coefficients or constants are just replaced with a value for the variable dependent upon the equation that I give you. So to go through an example of solving a literal equation, I want us to solve this specific literal equation for x. So in short, I want us to get x by itself by moving these variable terms. So in order to get x by itself, and I'm just going to rewrite it over here, the first term that I need to move is what is not with x, or undo the addition and subtraction like we first learned in two-step equations. So to undo the addition and subtraction first, I want to subtract b on both sides of the equation. So now I'm left with ax is equal to c minus b. You could have also done negative b plus c. I'm just going to keep it in order from my inverse operations. Now to fully isolate x, this is saying a times x. So I want to divide by a on both sides of the equation. And since I can't simplify c divided by a or b divided by a, I'm just going to leave it as a nice fraction of c minus b in the numerator all over a. So this would be the first step of this equation. I solved it for x. Now in step 2, I want to use this formula that I have created to fill in the different values of a, b, and c from the second part of my sentence to solve for x that way. I know that from this given equation, c, which is what I've been highlighting in pink, is equal to 11. So I would plug in 11 in the place of c in my numerator, minus b, we've been using green, is 5. So in the numerator, I have 11 minus 5 all over the value for a, which is 2. And I would go ahead and start to simplify. 11 minus 5 is 6 over 2, which simplifies down to 3. So it's a different way to possibly solve two-step equations, but I really like to have us practice this first step here of solving literal equations for a different variable. There is another example here where you'd once again be getting x by itself. To rewrite other equations where I don't need you to solve for the variable, I just ask that you rewrite it for a different value, are given on this slide. So here I want us to solve this function for y, which means I want to get y by itself. So if I want to get y by itself, I need to undo the addition and subtraction first. So I want to subtract away 3x from both sides of this equation. And I'm left with 2y is equal to 8 minus 3x, or you can write this as negative 3x plus 8. Then I want to go ahead and divide by 2 because this is saying 2 times y. So to undo multiplication, it's division. Now in this example here, I want to divide each of these individual terms by 2. So I'm actually going to rewrite it by showing the division under each of those terms that are getting divided by 2. And I would then be left with y is equal to 8 divided by 2 is 4 minus 3 over 2x because I can't simplify that. You could also rewrite this equation to put the variable first. So it could be negative 3 over 2x plus 4. And that is what you get when you solve for y. You're not supposed to have just one number as an answer. For this example, we're going back to solving for x. So I want to get x by itself. So the first thing I would do is add my 5y on both sides of the equation. And I'm left with 4x is equal to 15 plus 5y. And then to fully isolate x, I want to divide everything by 4. Divide and divide. I can't simplify any of these questions by 4 because neither of these are multiples of 4. So what you could do, if you don't want to just show two improper fractions, you could either leave your answer as 15 over 4 minus 5 over 4y, and that could be your final answer. Or you can just say 15, I'm sorry, that should be a plus sign. 15 plus 5y all over 4. I will take either answer. It's just important to notice that when you can simplify, make sure you do that. Here are a few other examples of solving for a variable, and I'm only going to focus on a few of them. One of them I really would like to focus on is this number 2 here. When I'm solving for a variable that's in the numerator of a fraction, I need to get rid of that fraction first. So to get rid of a fraction, the easiest way to do that is multiply both sides of the equation by the denominator. This denominator is b. So I want to multiply both sides of this equation by b, and it will be canceled out in the fraction, and then I would multiply u, also times b. I don't know what b times u is, so I'm just going to leave it as bu. Then the fraction is just equal to a times k. Then to get a by itself, I want to undo this multiplication. So to undo a times k, I would divide both sides by k. And my final answer for a would be b times u over k. And you're done. To move along to the geometric formula, since we did focus on triangles and rectangles at the beginning of last week in one of our warm-ups, we can rewrite those equations to possibly help us in the future. So I already gave you this formula, but the formula for the area of a triangle is A, which is area, is equal to 1/2 the base times the height. So that's what the little b and h stand for. I want us to solve this equation for h, and I'm just going to rewrite it so we can do the work directly next to the formula. And to start getting h by itself, I want to get rid of this fraction. And I really hope we are all starting to remember how to get rid of fractions that are in front of a variable. And that's that trick of multiplying by the reciprocal. So I can multiply both sides of this equation by the reciprocal of 1/2, which is 2. It cancels out the fraction on the right side, and then I'm going to multiply by 2 on the left side, and I just put it in parentheses to show that multiplication. And now I'm left with 2a is equal to b times h. To undo this multiplication of b times h, I want to divide both sides by b. And now we have h is equal to 2a over b. And that's how we would solve this equation for the height. And then what we could have done is, because I gave you the new formula for height, you could solve for it when I give you the base and the area by plugging those two values in for the variable. So you don't have to do inverse operations. I could just say the height is equal to 2 times the area, which is 64.4, over the base, which is 14. And then you would be able to go ahead and multiply the numerator first to start simplifying, and we would have 64.4 times 2 is equal to 128.8 all over 14. and then we would divide that answer by 14, and we would get that the height of this triangle would have been 9.2 meters. I also put on this slide the example for the perimeter of a rectangle, and this was that formula that I started to mention during that warm-up. And one of the ways we can use that formula to help us out is if we wanted to solve this formula for either the length or the width. Now, in this example, I wanted to solve for the width. So I'm going to actually erase that line that I just drew, and we're going to rewrite that equation to solve for W. Now, once again, I want to move everything to one side of the equation that is not with W. So I'm going to first subtract away my 2 times the length minus 2 times the length. And I'm actually going to rewrite this as P minus 2L is equal to 2W. And then to get W by itself, we divide both sides by 2. I'm running out of room, so I'm going to write it down here. And I'm going to have P minus 2L over 2 is equal to W. Now you can simplify this fraction and you could rewrite this as P over 2 minus, I'm sorry, not 2L. 2 divided by 2 is just 1, so minus L is equal to W because the 2's would cancel out there. And if we wanted to solve for the width, we can plug in our known length, we can plug in our known perimeter, and solve it that way. I hope this video was helpful to solve literal equations. Again, there's a few different extra practice problems from the textbook that I probably would assign for homework, a couple examples here to rewrite literal equations, and again, more examples here as well. Good luck, and I can't wait to teach you all again in person.